In the last video, we saw how carbon dioxide displays acidic properties when it's dissolved in water, and I offered an explanation as to why that occurs, and this revolves around the hydronium ion. We modified the Arrhenius theory to say that an acid is a substance that reacts with water to produce hydronium ions. Now, is there a similar explanation for basic properties of substances that do not have hydroxide in their formula? So here we see a molecule of ammonia, NH3, and I would ask you, where is the OH? If you look at the formula for NH3, you'll notice that there is no OH in the formula. So how is this basic? And if we test this out in a lab, we'll notice that a solution of ammonia dissolved in water in fact does have basic properties. It will have a basic pH. It'll have a pH probably around 11. If it's around 1 molar, 0.1 molar, it'll be somewhere around 11, which tells us it's a basic solution. Ammonia is an active ingredient in a lot of cleaning agents. You can use ammonia to clean different things in your house. Please do not mix it with bleach. That's a very bad idea. But ammonia can be used to clean things. So just like other basic substances that are also cleaning agents, ammonia might not necessarily have hydroxide in its formula. Okay, so how is it that ammonia is a basic substance? And that's what we're going to explain in this video. So what we actually see with ammonia, if we extend the definition of an acid being a substance that reacts with water to produce hydronium ions, perhaps ammonia reacts with water. Maybe we're discounting water. Maybe water takes part in this reaction. So let's figure out what happens. What would happen if we include water in the reaction? So ammonia plus water. And what we actually see here is that ammonia, in fact, is going to react with water. And ammonia actually reacts with water to form these two entities. First thing we make is ammonium, and the second thing we make is the hydroxide ion. So this partly explains why ammonia displays basic properties, because ammonia reacts with water to make ammonium and hydroxide ions. So a base isn't necessarily something that always dissociates to form hydroxide ions. A base can be something like ammonia that reacts with water to produce hydroxide ions. So we're still making hydroxide ions, but we're reacting with water in order to make those hydroxide ions. So we're going to offer this modification to the Arrhenius definition. So we'll call it the modified Arrhenius definition of a base. The modified Arrhenius definition of a base is that it's a substance that reacts with water to produce hydroxide ions. So that's the key point. It reacts with water. It doesn't always just need to be a simple dissociation reaction. So this doesn't discount the fact that you can have a lot of ionic compounds just simply dissociating in water to produce hydroxide ions. That still qualifies under this theory, but this modification brings in ammonia into the theory also. It explains why ammonia would also display these basic properties. It produces hydroxide ions and some ammonium ion. Okay, so that's kind of the explanation as to why ammonia is basic, and kind of a similar thinking can be used to explain basic properties of other substances that might not necessarily have hydroxide in their formula. All right, I'll probably do another video on this one explaining a little bit more about how you can tell if a substance is going to be acidic or basic just looking at its formula. It takes a little bit of intuition to do that, and this is definitely one of the trickier concepts to try to figure out without any sort of knowledge of further knowledge of acids and bases, but I'll try to do as much as I can going forward while still kind of staying within the parameters of Chemistry 20. All right, see you in the next video.